أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. I welcome you all in today's our online session of probability and statistics, or we can say the probability methods in engineering. We'll start today's session with some words of Holy Quran. In today's session of probability, we start today's session with some words of Holy Quran. Hopefully my voice is clear and screen share as well at your end. So we continue the session of probabilistic analysis, and I'm sharing the lecture uh, screen with you guys of probability. So last we discussed about the concept of statistical analysis of mod median, and today we discuss the concept of probability methods in engineering. So I need to rewrite it. Okay, the concept of probability. So last we discussed about the concept of probability and statistics, and this concept of probability, it is not the old concepts. All these are the concepts related of probability that we discussed in our uh, early A classes. So I, engineer Dil Khan, start the session of probability further. So the basic concept of probability and statistical analysis in engineering and technology, we need to discuss it further. Hopefully my voice is clear and screen share as well with you guys. So further, probability and statistics plays a central role in engineering and technology because they help deal with the uncertainty, वो चीज़ें जो कि गैर हतमी होती हैं, variability, uh, variability, and the data-driven decision making, and the data that is collect from the other kind of scenarios, and the statistical ways to implement these kind of concept in different aspects. So further, we take the decision on the basis of this scenario. In real world system, exact values are rarely known. So engineers rely on these tools to analyze, predict, and optimize the performance. So these tools of probability, for engineers, technologists, scientists, plays a vital role to analyze, predict, and optimize the performance. The models which create by the engineers, which creates by the technologists, scientists, are implemented because of these kind of things. So further, the major concepts of these probability deal with uncertainty and how it deals with. Engineering systems often involve unpredictable factors, noise, material defects, environmental changes further. And the probability helps model randomness, uh, random phenomena as well. For example, the failure changes of component. Further, the examples are estimating the probability of system failure in power grid. The probability of the power failure of a running system, how much the chances of failure of this system, etc., etc. So these are the uncertainty concepts, phenomena, and concepts which probability deal further. Data analysis and decision making. Statistics allow engineers to collect, summarize, and interpret data, helps in making informed decisions based on experimental or the field data. Example, analyzing test results to choose the best design. So, on the basis of data, we need to create model and implement the data on that particular model to drive the decision which are making further. Third concept of the course, quality and control improvement. Use in manufacturing to maintain product quality. Techniques like statistical process control, monitoring production in the production services, in production lines, supply chain management as well. So further, example, detecting the defects in the production line using the control charts. Reliability and risk analysis. Engineers are engineers use probability to evaluate system reliability and safety. Helps estimate mean time to failure and the risk level, that how much failure would be occur for the particular designated systems that we implement the model further. Example, prediction failure rates of electronic components uh, further are the examples. Signal processing and communication. So these are the applications further in which the probabilistic analysis in engineering different fields are implementing. In field like electronics and in telecom, randomness noise affects signals. So the noise effect in communication systems are a universal truth. We cannot neglect the concept of noise in communication, which is the major and important aspect which we need to avoid and eliminate in our models of communication. Probability helps model noise and improve signal quality. For example, the error detection and correction in digital communication systems. Further, machine learning and artificial intelligence. Many modern technologies rely heavily on statistical methods. Algorithms learn pattern from the data using probability models. So algorithms are the methodology data driven by which we take the response from the user and implement uh, the data on the particular system and get the desired output as per the user need. So further, many modern technologies rely on heavy statistical methods. Algorithms learn pattern of data from data using probability models. For example, the predictive system, recommendation engines, and automation. Or in automate industries and automation industries, most of the uh, preferable data and preferable models are implemented by the machine learning artificial intelligence ways. Forecasting and modeling. Many of the systems are based on the forecasting based analogies, and most of the data have already been recorded to implement these kind of methods by which we get forecasting and upcoming results from this modeling. Engineers use statistical models to predict future behavior. Example, load forecasting in an electrical system to traffic prediction. Experimental design helps design efficient experiments and interpret results accurately. Testing different materials to determine the strongest one. Control system. Further, probability is used in advanced control strategies like stochastic control, example, designing system that can perform well despite disturbances. Software engineering applications further using in performance analysis, reliability testing, and debugging, example, estimating the probability of software failure or bugs. Further, coming towards the conclusion of this concept of probability in statistics, that is the essential tool for engineers to handle uncertainties, the principle of uncertainty, the concept of uncertainties, and the model by which the data need to be collected, and the results would be unpredictable and uncertain. Make data-driven decisions, improve quality and reliability of the system as well, design efficient and intelligent system as further. So without these tools, uh, modern engineering and technologies, especially in area like artificial intelligence and communication and automation, would not be possible. So further, we moving towards the concept of probability of these are the related and relevance to the example of dice throw example. So dice throw example, coin of toys, a dice throw in one time, find the following. If we throw a dice one times, what will be its sample space of this experiment and the probability of if even outcomes appear, and the probability if odd outcomes if appear. So how can we solve this problem? And the scenario coming toward this, a dice is throw once. Sample space that we need to create for this would be a dice, dice of the game provide the outcomes 1, 2, 3, 4, 5, 6. If we throw a dice, the outcomes of 1, 2, 3, 4, and in the form of dots are appear on the particular scenario of dice. The second aspect is the probability of even outcomes, that how comes the outcome would be formed, that if we throw a dice, 2 can be formed, 4 can be formed, and 6 can be formed. So these are the three outcomes can be get out of 6 outcome. So how can we find the probability of even outcomes, that 3 divided by total number of outcomes. So 3 is the appeared outcome from this given scenario out of 6 total number of sample space. So 3 divided by 6, we got the probability of this even outcome is 1 upon 2, that is 0.5. So coming towards the third scenario of this question, that probability of odd outcomes. Odd numbers on a die are that if we throw a dice, then what will be the odd outcomes? 1 can be appeared, 3 can be appeared, and 5 can be appeared. These are the odd outcome by which it appears. Further, how can we find the probability of odd outcomes from this experiment? So total number of outcomes are 6 and the appeared outcome of odd are 3, 1, 3 and 5. So these are the three outcomes. 3 divided by 6 become 1 upon 2. So this is the example of odd outcomes, that how can we find this kind of concept. So you need to recall yourself this experiment. So I'm taking a short 1 minute of break over here. Okay, further we coming towards the aspect of define the axioms, rules, and the types of probability. The concept of axioms and other aspect of probability that we need to discuss further in next session. So up till now, if you have any kind of question, query, or difficulty regarding the session, I will answer the kind of question and resolve your queries if you have in your mind regarding the session. Hopefully all the things been clear at your end and have no query. So we end the session over here and continue next session with axioms of probability in upcoming sessions. Thank you very much.